Hello, this is Mrs. Nearing. In this video, we're going to talk through some problems related to percent yields. These are some stoichiometry problems. And the percent yield, as you can see by this formula up here at the top, is the actual yield divided by the theoretical yield. So the actual yield is what you actually collect when you do the experiment in a lab and weigh it. And then theoretical is what you expected to get by calculation. So theoretical you find via stoichiometry. All right, so we've got a first problem up here, and it says that suppose we react 1.203 grams of one of my reactants, NaBH4, with an excess of iodine. What is the theoretical yield of the reaction in grams of B2H6? So whenever I'm doing a stoichiometry problem, you can refer back to your mole map. And in your mole map, you should notice that your first step is in your problem solving process is always going to be to find moles. So right now we've got grams of our known, so we know grams of NaBH4. My first step is to convert that into moles. So I'm going to look up on the periodic table and find that 1 mole of NaBH4 weighs 37.84 grams. Okay. My next step in any stoichiometry problem is going to involve using the mole ratio to convert from my moles of my known to the moles of the unknown, the thing I'm trying to find. So in this case, the thing I'm trying to find is B2H6. So I'm going to convert moles NaBH4 to moles B2H6. Notice how the unit that I have goes on the bottom, the unit that I want goes on the top, and so that those will cancel out. And if I look at my mole ratios, it looks like it's a 2-to-1 mole ratio based on my coefficients. And then the last step is going to vary by problem, but in this case, they're asking for grams of B2H6. So I'm going to look up on the periodic table, and 1 mole of B2H6 weighs 27.67 grams. So I stop and plug it all in my calculator. I end up with 0.4398 grams of B2H6. And this is what we call your theoretical yield. This is how much product I should make in theory if everything goes perfectly in the reaction. And then reality is never perfect, right? So I actually go through and carry out this experiment in a lab and find that I collect 0.295 grams of B2H6. So the percent yield is what I actually got divided by what I expected to get. And I multiply that by 100 to turn it into a percentage. So I end up with 67.1% yield. And notice this problem up here has the first part B, has 4 sig figs. The second part has 3 sig figs because I'm limited by my actual yield, only has 3 sig figs in it. All right, so let's try another one. If you are not already given a balanced chemical reaction, you should always write one out. And this one's kind of, you're given it halfway. You given the reaction, but it wasn't balanced yet. So you got to balance it. And then we're given some volume and molarity information here, but our problem solving step is always going to be the same. So first step is going to be take your amount of known, which in this case is a volume of your known, and you're going to convert it into moles. So first step, find moles. All right, so we know that molarity is moles per liter. So to find moles of a solution, I'm going to take the molarity times the liters. So my molarity is 2.0, and my liters is 0.058. I got to remember to divide it by 1,000 to turn that into a liters value. And then that gives me 0.116 moles of H2SO4. So first step, find moles. Second step is always to use your mole ratio to convert moles of known to the moles of your unknown, the thing you're trying to find. So in this case, what I'm trying to find is grams of sodium sulfate. So I want to convert moles of H2SO4 into moles of the thing I'm trying to find, which is the Na2SO4. And if I look at my chemical reaction, it looks like it's a 1-to-1 ratio, so that's easy. Okay. And then my last step, they're asking me for grams. So I'm going to look at the periodic table and figure out how much a mole of sodium sulfate weighs. Looks like it's 142 grams. So if you go and you plug that in your calculator, you get 16.5 grams of sodium sulfate. This is your theoretical yield. And then you go through and actually do this reaction in the lab, and you collect and dry and weigh the solid, and you find that actually you only collected 13.6 grams. So you're going to turn that into a percentage. It's what you actually got divided by what you expected to get, and plug that in your calculator. You should get 82.4%. That is your percent yield. All right, so let's try one more problem here. Let's look at this one. And we are, again, our steps are we're going to start with our known. We're going to convert our amount of known into moles of known. Then we're going to use our mole ratio to find moles of unknown. And then we're going to convert moles of unknown to grams. So think about your mole map. Notice how every single one of these problems has involved a mole ratio step. So you need the balanced chemical equation for that. All right. So first step, let's figure out what we're being given. We're given this value, 5.23 grams of SCl2. Okay, and I'm trying to find the yield of S2Cl2. So I'm trying to go from grams of this to moles of this. Okay, so first step is to convert grams SCl2 into moles SCl2. So I'll look up at the periodic table and say that 1 mole weighs 103 grams. Next step is I want to use my mole ratio to go from moles SCl2 to moles product S2Cl2. And looking at your coefficients, looks like it is a 3-to-1 ratio there. And then my last step, my theoretical yield, is kind of unclear in this problem. Let's figure out our theoretical yield in terms of grams. So I'm going to convert moles of S2Cl2 to grams of S2Cl2. Again, looking at the periodic table, it's 135 grams. So my theoretical yield is 2.28 grams. And then this question, it's phrased a little bit differently. So if the reaction typically has a percent yield of 65%, what do you expect your actual yield to be? So basically you're just saying, like, what's 65% of 2.28? That's what I would expect my actual yield to be. And if you plug that in your calculator and you round it to 2 sig figs, you will get 1.5 grams as your predicted actual yield. All right. Thanks for listening.